All right, we are going to continue working with comparing slope or rate of change with a verbal description. I have three different functions here that we're going to take a look at. So if we read what it says first, it says 3 friends were in a race. Find the slope for each to determine who ran the fastest. So we have to find the slope and we want to know who ran the fastest. So the first one that we're going to look at is Steve, and Steve is represented with an equation that says y equals 4.5x. If I have to find the slope for each, I know that in an equation, slope or rate of change is the coefficient to x. So Steve's slope or rate of change is 4.5x, or just 4.5, sorry, not the x. If I'm looking at Cam is in a table, so I know that to find the slope of a table, I need to find my change in y over change in x. So if I'm looking at this, Cam starts at a 4, my next value is a 9, so that tells me I added 5. We want to make sure that's true for the whole table. 9 plus 5, yes, that gives me 14. 14 plus 5, yes, that gives me 19. So my change in y was a 5. Now we want to go over here to our x values, our seconds, and find out how that's changing. 0 to 1, I added 1. 1 to 2, I added 1. 2 to 3, I added 1. So my change in x is a 1. So we can say that Cam's rate of change or slope is 5. And then my last one over here, Stephanie, she's represented by a graph. It's really important when you're dealing with graphs that you're paying attention to labels and how the intervals are numbered. So down here, my x values represent my seconds. My y values represent meters. So it looks like down here they go by a half. So half 1, 1.5 2, 2.5 3, 3.5 4. And my y values go by 2. So 2, 4, 6, 8, 10, 12, and so forth. So if I'm looking at this, we have meters and seconds, and Cam we had meters and seconds. So what this is telling me is how many meters are they running in a total number of seconds. So if I look at this, I want to find this ordered pair. So what I'm going to do is I'm going to follow this on down. Looks like that goes to the 1. And if I follow this over, that's a 4. They go by 2, so that's going to be a 6. So my ordered pair, when x was 1, y was 6. Let's find my next ordered pair. If I follow this down, that goes to a 2. So when x was 2, looks like y was 12. And we can keep going. There's another friendly point right there. You have enough information now to find the slope or the rate of change. So you guys learned previously the formula y2 minus y1 over x2 minus x1 will give you the rate of change or the slope between 2 points. You can also make a triangle. Now when you're doing this, you want to make sure that you're counting by the right amount, because remember, these go up by 2s. So from 6 to 8, that was 2, 8 to 10, 4, and 10 to 12 made it 6. So my change in my y values, I went up 6. Now my x values, this is 1, and I jumped over to 2. So I went from 1 to 2. So my change in y was just 1. And that can be simplified down to say that my slope for Stephanie is a 6. So now I have all of my slopes, and I can start to compare them. So what these would tell me, I have a 4.5, I have a 5, and I have a 6. So this is how far they went in a certain number of seconds. So because these are all represented as whole numbers, we know that's how far they went in 1 second. So it says who ran the fastest. So I have a 6 meters in 1 second, 5 meters in 1 second, and 4.5 meters in 1 second. So if we look at this, whoever ran the farthest is who ran the fastest because they all ran the same amount of time for 1 second. So in 1 second, Stephanie ran the fastest because she went a total of 6 meters. Next, I have a 5 and a 4.5. So Cam would be the second fastest because in 1 second, he ran 5 meters. And then Steve would have came in third place because in 1 second, he ran 4.5 meters. So there's just another example on how you can compare finding slope based on this one. We had an equation, a table, and a graph. And then make sure you're paying attention to what the question is asking you. That way you know how to correctly answer this question. I hope this helps, and I hope you are all doing well.